All right, guys, welcome to our 6.1 Unit 6 Quiz Study Guide 1. Let's go ahead and get started here. I'm going to do all the problems on this video. Let's begin. Number 1 says, which of the following is a quadratic binomial? So this is a vocabulary check. You might want to look at your 6.1 notes because in there's a list of vocabulary words that will help you. Quadratic means that we have the highest power is 2. Okay, so there are two options where the highest power is a 2. But now we also it needs to be a binomial, which means there's two terms. So B can't be it. That's a trinomial. It has 3 terms. So the answer here would be C. That's a quadratic binomial. Number 2. Which of the following is a linear monomial? All right, linear means the highest power is a 1. Okay, so there are two options for that. This one's highest power is a 3, and this one's highest power is a 2. So the bottom two choices there are linears, but it needs to be a monomial. Monomial means there is only one term. So since D has 2 terms, that's not it. C is a linear monomial. Number 3, we're going to talk about adding and subtracting with polynomials. So the one that has a minus in front of it is going to have the minus distributed to change all the signs. So the 2 into the third becomes negative, the 8 into the fourth becomes positive, and the 2n squared becomes positive. But the other polynomials there don't have negatives in front of them, and so they're going to stay exactly as they are. Next, we're going to combine our like terms. Like terms are two terms that have the same variable and power. So this is a 5n here, and it has a power of 1. So we're looking for another term that has an n to the power of 1. Let's see. I see only one more. It's right here. So we're going to go ahead and combine those together. 5, now when you combine them, you just combine the coefficients, the numbers in the front. The n will stay the same. So 5 take away 6 is a negative 1n. All right, let's move on to the next one. This is a constant, which means it doesn't have a variable. And it's a like term with another constant over here, which is negative 3. So we'll go ahead and combine those. 5 take away 3 is 2. It's a positive 2, so I'm going to put a plus 2. Next, we have this negative 2n to the fourth. We're going to combine that with any other terms that have an n to the fourth power, which would be right here. So that would be a negative 2 plus 8 is 6n to the fourth. Next, we have an n to the third power, which can be combined with this other n to the third power. Negative 2 plus 8 is 6n to the third. And then finally we have this 2n to the second power, which doesn't have any terms that it can combine with. There's no terms that are like it. Lastly, we'll want to put our polynomial in descending order. We start with the term that has the highest power first, and then we work our way down. The next power would be the third power. The next power would be the second power, followed by the first power, and then the number that's a constant always comes last. And so there would be our final answer for that. Let's go ahead and move along here, and we'll check out number 4. Number 4 is a multiplication problem. Whenever you have two expressions that are right next to each other with no plus or minus between them, that's multiplication. And in this case, since it's just a monomial outside the parentheses, we're going to treat it like just a distribution problem. So when you multiply monomials, you multiply the coefficients. So 5 times negative 2 is negative 10. And when it comes to the variables, r times r squared, you add their exponents. So this one has a 1, and this one has a 2. So 1 plus 2 would be 3. So it comes out to be 10r to the third. And we repeat that process for the next one. So I'm going to multiply 5r times 7r. 5 times 7 is 35. And 1 plus 1 is r to the second. And then lastly, we'll do 5r times negative 8. 5 times negative 8 is negative 40. And since the 8 doesn't have an r, this r remains unchanged and it just stays as a regular r. And there is our result from multiplication. So that's distribution. That you use that strategy whenever you just have a monomial multiplying a polynomial. So this is my monomial, that's my polynomial. You distribute the monomial. Let's take a look at another multiplication problem. This one is a binomial being multiplied by a binomial. All right, now the way we learned that in class was we looked at how many terms each expression had. This one has 2 terms and this one has 2 terms. And what we're going to do is we're going to make a 2 by 2 box to multiply these things. So 2 spaces wide and 2 spaces high. Along the top, we're going to put one of our binomials, the negative 4x minus 4. And down the side, we'll put the other one, negative 7x minus 4. And then we're going to multiply the terms to fill in our box. So to find out what goes here, I'm going to multiply the term above it and to the left of it there. So negative 7 times negative 4 is 28. And x times x is x to the second. To find this number, we're going to multiply the number above it and the number out here to the left of it. So negative 7 times negative 4 is 28. And since only the negative 7x has an x, the x just stays that way. It doesn't get altered. And to find this square here, we're going to multiply the negative 4x by the negative 4. Negative 4 times negative 4 is a positive 16, and the term on the top has an x, so we'll have an x there. Lastly, to find this square, we're going to multiply the negative 4 times the negative 4, which is 16. Now what we're going to do is we're going to take these terms out in descending order. So this would be my greatest term here, 28x to the second. Then we have these two, which are both to the first power. It doesn't matter which one you put first. And then finally we have the constant, which comes last. And if there's any like terms we combine, then we should. So here, these are like terms, so I'm going to go ahead and add those together. 28 plus 16. That would be 44, I believe. And then we have 16 at the end. And there's our final answer. Number 6, this time we're doing a binomial times a trinomial, which means we need to have a 2 by 3 box. So I'll make my box 3 spaces wide and 2 spaces high. Along the top, I'll put the trinomial. And down the side, I'll go ahead and put the binomial. And we'll go ahead and multiply to fill in our box in a manner similar to what we did on the last problem. So here we would have 36 n to the third. Here we would have negative 18 n to the second. Here we would have 6n. On the bottom left, we would have negative 30n squared. After that, we would have 15n. And finally, we would have a negative 5. Now, instead of taking all the terms out and putting them in descending order, what we can notice here is that we have like terms that are diagonal from each other. I see that my first term that I'm going to use, the one with the biggest power, is going to be 36 n to the third. So I'll just bring that out now, and then I'll ignore it. But after that, the biggest power is a power of 2, and there's 2 of those. Instead of writing them and then combining them, I'm just going to combine them now. So what is negative 30 combined with a negative 18? That would be negative 48n squared. So there's that. The next term would be n to the first power, and there are 2 of those there. So 15 and 6 combined would give me 21n. And then finally we have the constant at the end. And there's our final answer for that one. All right, number 7. On number 7, you could use the box method again. There's our answer, but we'll get to that in a minute. But in this sense, I want you guys to notice that this is one of our shortcuts that we learned. Shortcuts are nice. They make things faster, okay? Anytime you have the same thing, but opposite signs in the middle like that being multiplied together, the result is always going to be A times A and B times B with a minus in between them. You could do the box. You'll get the same answer. It's just that it's a lot faster if you know the shortcut. So 8n times 8n is 64n squared. And negative 1 times positive 1 is a negative 1. Much faster than the box method, but you have to recognize when you're allowed to use that shortcut. You're only allowed to use it when they're exactly the same. It's just they have opposite signs in the middle. All right, let's go ahead and take a look at number 8. This is another one of our shortcuts. When you have 7b minus 6 to the second power, that means you're multiplying it by itself. So this time you're multiplying identical binomials. And we learned a shortcut for that as well. Whenever you have a plus or minus b squared, the result is going to be a squared, b squared, and in the middle it's going to be 2 times a times b. This sign will depend on whatever was here. So if it was a plus, it'll be a plus. If it was a minus, it'll be a minus. But the last one will always be positive. So there's our shortcut. All right? So we have a times a gives me a squared. That would be 49b squared. We have b times b, which is going to be 36. Now in the middle, we're going to have a minus because we're dealing with a negative here. And it's going to be 2 times the a term times the b term. The last term will always be positive. So we need to multiply these. Oops, let me back up a little bit. I shouldn't have put that minus there actually because we already did that. There we go. All right, so we have 49b squared. Here we have 2 times 7, which is 14, times 6. 14 times 6 is 84, and there's a b, so we'll put the b there. And it's going to be minus, once again, because of that minus there, plus 36. So that's another one of our shortcuts. So we want to recognize and use the shortcuts when possible. All right, so in this particular question here, we are doing a review question. We're solving a system of equations. A system of equations is where you have two equations with two variables, and you're looking for the value for those variables that would work for both equations simultaneously. We learned a few strategies for solving these, and one of those methods is the one we're being asked to use here, which is substitution. Substitution is the strategy where you find the lonely letter, you circle what it equals, and you plug it into the other equation for that variable, which would give us this. And then we're going to go ahead and start solving. So we'll do our multiplication first here. Then we'll combine our like terms. And then we'll divide both sides by the coefficient to get the x by itself. And we get x equals -1. Now we also have to find the y. So we're going to take our answer that we got here for x, and we're going to plug in -1 for x. And you could use either equation, but I recommend using the one with the lonely letter. So y is equal to -5x, but we're going to replace the x with -1, which gives us 5. So y is 5 and x is -1. Let's go ahead and take a look at number 10 here. On number 10, we're being asked to solve another system of equations, but this time we're going to be using the method known as elimination. So with elimination, the first thing that you're going to do is you're going to pick a variable that you would like to eliminate. I'm going to choose to eliminate the x variables. After that, what you're going to do is you're going to take the coefficients of the x variables, you're going to flip and distribute them. So I'm going to put the -9 up here and the 7 down here, and I'm going to distribute them into those equations. And what that's going to end up doing is going to make the x terms end up having the same value. So let's do that. Negative 9 times the top would give me this. And multiplying the bottom equation by a negative 7 would give me this. All right, now I want these variables to eliminate. Right now, they're not going to eliminate because they're exactly the same. But if I can make them opposites, then they can eliminate if I combine them together. The way we'll make them an opposite is we'll multiply one of the equations, I'll do the bottom one, by a negative 1. And what that's going to do is change all the signs so that they're opposites. The top equation will stay the same. The bottom equation will become this. Now we can combine these equations. I'm going to add my x's together, which will eliminate them. I will add my y's together. 81 take away 35. Let's see, I believe that'll be 646 if I'm not mistaken. And then adding my constants together here, I'm going to end up with negative 138. Now I'm going to divide both sides by 46. And we will know that we did this right if we don't end up with a decimal. Not because it's impossible to get decimal answers, but because I told you I won't be giving you questions that result in decimals. So it comes out to be a negative 3, which is perfect, which means we're probably on the right track. Now we're going to take that answer, because that's half of our answer, right? But we also need to find the x. So we're going to take that answer. We're going to choose one of our equations. It doesn't really matter which one. And we're going to replace that variable with that value. So I'm going to replace the y with negative 3 in the top equation. Let's do our multiplication first. That's going to be a positive 27. Let's get rid of this 27 by subtracting it on both sides. And then we'll divide both sides by a negative 7 to get rid of that coefficient. And we end up with x equals 3. So there's our final answer there. X is 3 and y is a negative 3. The answer will probably be written as a point on your quiz, where the x comes first and then the y comes second. All right, moving along to number 11. Last question here. We're also going to review how to solve a system of inequalities. That's whenever you have an inequality here. The only way to solve those is by graphing. So let's go ahead and get started. All right, I'll graph this one first. My y-intercept is 3, and my slope is a negative 2. So I'm going to go down to right 1 from my starting point. Since my inequality does not have an equal under it, we're going to connect those dots with a dotted line. And since it says y is greater than, we're going to be shading above that line. So any point in this shaded area contains an x value and a y value that would work for that red equation there. Let's go ahead and do this one now. My y-intercept for that one is a negative 1. The slope is a positive 2 over 1, so I'll go up 2 over 1. We do have an equal sign underneath of it, so we will connect it with a solid line. And since it says y is greater than, we'll shade above that one as well. And any part that is being shaded blue here is a solution to the blue equation. Now we're looking for the part of this equation that has points that work for both, and that would be the purple area, because this is shaded both red and blue, and that's why it looks purple. And so those are the points that would work for that pair of inequalities, and those are the solutions to that system of inequalities. All right, and that'll do it for our Unit 6 Quiz 1 study guide. Hopefully that was helpful, and we'll see you guys in class for your quiz. Till next time, have a good time.